Good day, Dr. Aziza and everyone. We are Group 7, and today we are presenting our project for BCN2173 operating system. Here's our group member, and now I will pass to our next member to start the first point.
Almia is biometric authentication and is used with the operating system. Biometric authentication is a method of verifying user identity using unique characteristics such as fingerprints, facial recognition, iris pattern, or voice recognition. The process consists of four phases. First, the capture, where biometric data is collected. Second is extraction, where unique features are converted into a mathematical template. Third is comparison, where the new biometric data is compared with the stored template. Finally, in the decision phase, the system either grants or denies access based on the matching result. The operating system supports this process through authentication and access control, which prevent unauthorized access, and encryption, which protects stored biometric data. The operating system supports this process through authentication and access control, which prevent unauthorized access, and encryption, which the operating system also manage biometric device, allowing environment verification and communication between hardware devices such as fingerprints, scanners, cameras, and microphones. That's all. Thank you. The operating system also manage biometric device, allowing environment verification and communication between hardware devices such as fingerprints, scanners.
Thank you, Aina, for your explanation. Now we move on to 2.0, which is network organization and OS integration. According to section 2.1, the system use physical trait like fingerprint or facial recognition to verify who you are, which requires secure communication with remote servers. Next, 2.2, client server biometric authentication model. Break this down into a simple 5-step model. Your trait on the client device, the local OS convert into template. Next, sends an authentication request to the server, and the lastly is the server verifies it, whether it's either granted or be denied. So next, section 2.3, we look at how this highly sensitive data is protected while traveling over the network. To keep your biometrics safe from hackers, the system relies on two main pillars, which is TLS encryption. TLS encryption, which locks down the data from unauthorized access, and second one is cryptographic hashing, which ensure the data is not tampered with during transit. Authentication protocol in network operating system. First one, we have FIDO. FIDO is a passwordless standard where your biometric data stays entirely on your local device. Only secure cryptographic keys and share with the server, making it highly phishing resistant. In other hand, we have also SSO, which is single sign-on, which allows you to log in just once using secure tokens to safely access multiple system without repeating your password. And finally, section 2.6 and 2.5, which is 2.5. In overall, the OS network manager act as the ultimate bridge. It enforces security policies and manage remote servers communication, while the core OS handle local biometric processing and access control. Together, they create seamless, secure verification environment. Thank you.
I'm Chambeyin, CD25060. Now let's look at the section 3.0, security threats and ethical considerations. First, biometric system can be abused to track students or workers without them knowing. Second, stolen face data cannot be reset. This causes the biometric birthday problem and unlocks wrong accounts. Last, public cameras collect faces without user consent. Next, for specific traits, hackers can use 3D printed masks to trick sensors like Face ID. Also, they can break through ACL permissions to steal database files. This causes permanent failure because biometric records can never be changed. Finally, replay attacks can steal network signals to fake identities. For OS flows, buffer overflow in device drivers lets hackers run bad code to bypass login. This leads to privilege escalation from user mode to kernel mode. To fix this, administrators must do two things: use strong data encryption to make files unreadable, and combine strict ACL with MFA to block stolen passwords.
My name is Xuan. For Section 4.0, we evaluate Apple Face ID Enterprise Framework across three components: the device subsystem, secure enclave, and network manager to weigh its real-world impact. We will connect this to theoretical concepts: hardware-level isolation defense and cryptographic challenge response protocols. First advantage is hardware isolation successfully defeats buffer overflows. Raw data goes directly to the secret enclave, while memory integrity enforcement completely locks hackers out of the biometric buffer. Second is phishing and network replay attacks mitigation. Our FIDO tool integration provides powerful network defense. Under the match-on-device principle, biometrics never leave the chip, and domain-bound tokens combined with dynamic challenge fully block replay attacks. However, it also has disadvantages. The cross-platform deployment faces high rates of API misuse. Research shows a shocking 97.15% misconfiguration rate on open systems. Attackers can easily bypass physical chips through broken software code to achieve privilege escalation. Finally, there is a heavy hardware dependency. Environmental dust and humidity easily degrade 3D sensors, leading to frequent false rejections that block valid employees and create massive operational overhead. Thank you.